So today I'll be conducting an instructional lesson using base 10 blocks to complete multiplication problems and also doing a little grouping on the side. So normally kids use normal algorithms to complete their problems. So for instance, 5 times 5, 4 times 4, 3 times 3 is how a student is normally used to seeing a problem. So of course 5 times 5 equals 25, 4 times 4 equals 16, and 3 times 3 equals 9. But using base 10 blocks is a way where we can make solving problems much more interactive for students visually, especially for students who are visual learners. So with base 10 blocks, what happens is they come in forms of ones, tens, hundreds, and thousands. So base 10 block for 1 would be this little unit right here. For a 10, it would be this rod. For base 10, for 100, it would be this flat. And for 1,000, we won't be using this today, but for 1,000, it will be this cube. So what we're gonna do now is create a multiplication problem and use base 10 blocks. So we're gonna throw in another manipulative, and I'm gonna use a quarter for our multiplication sign. As you know, as kids get older, when they get into high school, they'll use algebraic forms where they'll use a dot instead of an X to be the symbol of their multiplication sign. But for today, we're going to use this quarter as a multiplication symbol. So if I were to do 10 times 2 using base 10 block, what I could do is I could take this one rod, count that as my 10, and then put these 2 units here and use that as my 2. So this would be our symbol for 10 times 2. And obviously 10 times 2 equals 20. So our answer for 20, we could get it in multiple forms. We could have either 2 rods equal 20, or we could have 1 rod and 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5. So 2 sets of units that have 5 in them. So what we'll do now is we'll do another problem, but this time around we will focus on grouping. So what we'll do, focus on grouping. That seems not to be erasing, but we'll have to call audible. So we're gonna do problem, we'll do 7 times 5. So obviously these all comes in one. These are only able to come in ones, so we will not be using a flat. We will not be using any rods, or for sure we'll not be using the units. I mean for the cubes. So 7 times 5. We'll take 7 units right here. 1, 2, 3, 4, 5, 6, 7. So there's our 7, quarter, our multiplication sign, 5 more units. 1, 2, 3, 4, 5. And that is our symbol for 7 times 5. And obviously 7 times 5 equals 35. So we could have 3 rods and 5 units. 1, 2, 3, 4. 1, 2, 3, 4, 5. And that's our symbol for 35. So if I wanted to tell my students, just switch it up, because there's more different ways in which we can get 35. That's not just the only way. How many groups of base 10 blocks would it take to reach 35? So let's say if I were to do it, if I wanted to form 7 groups using 35 to get 35, I could use all ones. And so here's one group for me. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 6, 7. 2, 3, 4, 5, 6, 7. So obviously you can see these 5 groups of units with 7 rods, with 7, these 5 groups of units with 7 units in them in each group would equal 35. So as you can see, this is just a fun way, interactive way for students to learn math, especially students who are visual learners. There's multiple ways you could get 35. For instance, put these 3 rods here, 5 units, 35. And it's just a different way where students could express their imagination and show that they're able to grasp the information that they're learning. So once again, base 10 blocks comes in 4 formats. So they come in units, which equal 10, which equal ones. They come in flats, and they come in rods, which equals tens. They come in a flat, which equals hundreds. And they come in 1 cube, which is thousands. Thank you for your time, and I appreciate you watching my lesson.